Hi everyone, I am here to write programs to find nth Fibonacci number using three approaches: iterative method, recursive method, and tabulation method of dynamic programming. So our aim is to find nth Fibonacci number, using first iterative approach, then we will also see how this nth Fibonacci number can be found using recursive method, and then we will see how this nth Fibonacci number can be found using tabulation method of dynamic programming. Okay, so let us start writing program for finding nth Fibonacci number using iterative method. Iterative method. The time complexity of this iterative method is big O of n. We all know that the Fibonacci series starts with 0, 1. Let me take two variables a to hold the first value of Fibonacci series and b to hold the second value of Fibonacci series. This is 1. Okay. We have to read n value actually. First let me do that one. Then a is set to 0, b is set to 1. If n equal to 0, the nth Fibonacci number, the 0th Fibonacci number will be 0, print a. Else n equal to 1, if n equal to 1, print b. The first Fibonacci number is 1. Else, let us start with I value 2, then while I less than or equal to n is the input, we have to find nth Fibonacci number. What I will do is, I will take some third variable c, which will hold the sum of its previous numbers, c equal to a plus b. Later on, what I will do is, I will assign b to a, and I will assign c to b. Then increment I value by 1. If I reaches n or I crosses n, it will come out of the while statement. Then we have to print nth Fibonacci number equal to this c will hold that nth Fibonacci number. That's all. Let us see the code once again. We are following iterative method. Iterative method is nothing but using loops to carry out repetitions. The time complexity of this method is big O of n. We have to read n value from the user. Then initially we are setting a to 0 and b to 1. Then if n equal to 0, print a, n equal to 1, print b. Else start with 2 and until this I value reaches n, proceed like take third number c. C is the sum of previous two numbers, that is a and b. Then update a value and b value for next iteration, that is b is assigned to a and c is assigned to b. Then increment I value by 1. I is loop variable here. Once this I crosses n, the loop will stop its execution. Now whatever the value that is there in C will be the nth Fibonacci number. Let us run this code and see whether our code is working properly or not. Let me take 5. If the code is correct, the output for this program should be 5. Okay, so we are getting the correct output. Next, let us see another method. Finding nth Fibonacci number using recursion. The time complexity of this recursive method is, though the recursive definition of Fibonacci number is an efficient one, the time complexity involved in executing this recursive method is very high, that is 2 power n. Big O of 2 power n. So as it is a recursive method, we must write a function def fib of n if n equal to 0 or n equal to 1, return n. This is stopping condition or exit condition. For any recursive function, we must mention the stopping condition or exit condition. Otherwise, it can never stop at any point and it will fall into infinite loop. Then, if n equal to 0 or n equal to 1, return n. Else, we have to return fib of n minus 1 plus fib of n minus 2. So fib of n minus 1 is n minus first Fibonacci number and fib of n minus 2 will give n minus second Fibonacci number. Fib of n is equal to fib of n minus 1 plus fib of n minus 2. This is the recursive definition for Fibonacci numbers. Then let us write the driver code. Read n value from user. Now we can call this function fib of n. So before that, let me write this message: nth Fibonacci number equal to comma fib of n. That's all. Now let us write this code. Let us execute this code for n equal to 5. If our code is correct, we must get the output as 5. Yes, we got it. This is the recursive method to find nth Fibonacci number. Now let us see the third approach, that is tabulation method. Tabulation method of dynamic programming, and its time complexity is big O of n. So it is an efficient approach when compared to recursive method. When we have to deal with large values of n, this tabulation method of dynamic programming is very efficient. Let us see how does this code turns out. So first I will be taking one array or one list Fibonacci fib, and initially I assume all the elements as 0, and I will take n plus 1. What is this n? This n is to be read as input. N equal to int of input, enter n. Then I will create a list of size n plus 1. Initially all the values of this list are set to 0. Then we will initialize fib of 0 to 0 and fib of 1 to 1. Then for I in range 2, n plus 1, 2, n plus 1, fib of I is equal to, please observe, instead of function calls, what am I writing? I am using index variables I minus 1, I minus 2. Why? Because we are storing the computed results in the form of a list and then we are accessing them. So because of this reason, it will consume very less amount of time compared to recursion. Fib of I minus 1 plus fib of I minus 2. That's all. Finally, let us print the output. Nth Fibonacci number can be found at fib of n. That's all. Let us run this code and check whether it functions properly or not. 5. What is the output we are getting? Fifth Fibonacci number is 5. So these are the three methods by using which we can find out the nth Fibonacci number in a Fibonacci series. What are these three approaches? The first one, iterative method, which consumes big O of n time complexity. Second one is recursive method, which consumes big O of 2 power n time complexity, which is very huge and it is quite dangerous when n is large. The alternative is tabulation method of dynamic programming, which is an efficient method when n is large. I hope you understood all these three methods. You can try them on your own and you can pause the video to have the code of these programs, and you can experiment with different inputs. Thank you.